Good day everyone. I am Nimeshi Delpachitra from Uvellasa University. This research is about fabrication and characterization of an environmental friendly packing material using banana fiber composite. In general, for packing material, many people tend to use non-biodegradable materials such as polythene and plastic because of low cost, low electrical conductivity, transparency, stiffness and low density. But from the aspect of environment, it's really harmful to the ecosystem. The objective of this project is to find out an alternative biodegradable packing material using waste material, that is banana pseudostem, as it becomes waste material after harvesting. In order to make the specimens, first banana sheets were cut into small pieces and boiled with water. Then banana pieces were crushed and blended until maximum amount of fibers separate from the banana chips. The extracted fibers were mixed with heated wheat starch solution, and then the pulp was poured into a mold. 6 specimens were prepared using 100 grams of banana fibers with varying amount of wheat starch. Figure 1 shows the 6 prepared composite samples. Finally, the tensile strength properties of the specimens were measured via universal testing machine. According to the result showed in table 1, sample number 3 showed maximum 115.11 Newton load over the other samples and shows tensile stress as maximum load is 1.01 megapascal and also extension at maximum load as 1.066 millimeter. This is a good trend to use this natural composite for applications such as small bags, envelopes, various cards, and also this can be improved further to use as a food packing material. In order to do that, it must carry out microbial test, and for thermal properties it must be carried out, and pH test and all the tests related to qualities. So finally, it can conclude that according to the result obtained from this project, banana starch composite can be used to bear small loads. As it shows, it can bear 1 megapascal tensile strength, which is equivalent nearly 10 Newton load approximately. Thank you.